Okay, so I believe we can start. And let me first introduce myself. My name is Orest, and I'm a solutions engineer here at StarWind. So today's our topic is StarWind VTL as part of the backup infrastructure and its place in the 3-to-1 backup rule. So first of all, let's take a look at the agenda and what are we going to talk about today. So first, we're going to focus on the role of the backups in the modern IT infrastructure and take a look why the backups are of course important. We'll then move to the famous 3-to-1 backup rule and how we should properly approach our backup infrastructure. Then we'll shortly talk about the StarWind VTL, of what it is and how it functions. And after that, we're gonna try to understand how StarWind VTL can help us and fit the famous 3-to-1 backup rule. After that, I'm going to show you how to properly deploy StarWind VTL, and in the end, as usual, we'll have a short Q&A session to answer your questions. So let's actually move forward and take a look at the role of the backups. So why actually decided to tell about the importance of a proper backup infrastructure? Well, while it might seem as something obvious and as pretty much any business values its data, the role of the backup infrastructure often gets underestimated or misinterpreted. So what's the main goal of the backups? Well, of course, it's to allow you recover your data in case something unexpected happens to the primary working data set. This can be simple data corruption, deletion by mistake, as any company is prone to the human error, or any malware that will encrypt your data. In addition, just to allowing recovering your data in the worst case scenarios, the backups can maintain a history of your data, allowing you to retrieve it months or even years back in case needed. This, of course, depends on your retention policies. And when I'm talking about the misinterpreting of the backup, there are a few cases I wanted to touch. The first one I hear quite often is RAID as my backup. And while RAID is great, its main goal is to provide uptime for applications and services. But there is much more that can happen to your data besides a drive failure. So keeping the proper backup separately from your primary working data set is a must, as it again can protect against malware, corruption, human error, and many other possible failures. The other case is when DR is interpreted as same as a backup. So while disaster recovery and backup as concepts sound familiar, there is quite a difference between them. First of all, DR is the strategy that involves different mechanisms in order to effectively respond to a disaster event and can include or not backups. Backup, on the other hand, is a process of creating copies of data and can be a part of your DR strategy. Now, just to note, there are of course different interpretations of disaster recovery, and different companies use this term in different meanings and according to their needs. So of course, this can vary. So overall, disaster recovery is more about the ability to quickly reestablish access to applications, data, and IT resources after an outage. That plan might involve, for example, switching over to a redundant set of servers and storage system until your primary data center is functional again. For such cases, you most likely will want to use asynchronous replication with a tight schedule and automatic failover to minimize the possible downtime. But overall, this is all about your RTO and RPO requirements. Saying simply, having backups doesn't mean you have a DR plan and that you can ensure business continuity. Just as well, having an asynchronous replication to some offsite servers does not mean you have a backup, as you cannot restore data from weekly or even further monthly or yearly history. And of course, when talking about backups, the important thing to understand is that actually backing up data is one thing and restoring it is another. So you should have a recovery plan in place for different scenarios. One in which your infrastructure remains intact, but your data is lost, in which case you can recover from backups to your original infrastructure, and another for a situation where you need to stand up totally new infrastructure and then recover data to it. And of course, this basically is more of the approach rather than some technology or software that would do the trick for you. And of course, having backups is great, but it's not a rare case when they are never checked, and when there comes a need to restore from them, you suddenly find out that the backups were failed and they do not really contain any data that you need. So the other hint basically is to constantly and periodically check your backups to make sure the data is really there to save you in the worst case scenario. So what is the industry standard approach to overall backup strategy? Well, it's the well-known 3-to-1 backup rule coined by multiple backup vendors. And although you can find variations of this, the common approach is 3 copies of data on 2 different media and one of them offsite. So 3 copies of data are your working data and 2 backup copies. So these 3 copies should reside on 2 different media. For example, working data on SSDs and your 2 backup copies, for example, on HDDs. However, I also want to note that different media types do not necessarily mean different storage media type as such. For example, you can have your working data set on HDDs and backups too, but in that case, preferably from the different supply pack, so that in case one supply of the HDDs has the failed ones or with some bugs, most likely if you're using all the HDDs for backups and for primary data from the same supply, it is quite a chance that something will go wrong also to the HDDs used for backups. But again, the different media can very well include same HDDs or same SSDs, but just from different supplies. And now, one of those 2 backup copies should be kept in some remote location in a meaningful distance when, in case of some disaster, your data can be restored. So probably having 2 backup copies in different rooms in the same building is not the best idea. And of course, if you do not have such an option or don't want to give your data to backup facilities providers, you can use cloud. So speaking of cloud, there are quite a lot of options nowadays, with AWS and Azure providing their archive tiers with low pricing, becoming quite an option for that 3rd copy of data that will be stored in cloud instead of the actual offsite location. So before we go to the VTL and how it fits the 3-to-1 rule, let's actually try to understand what VTL is. So, well, the physical tape itself is considered as the most optimal media when it comes to longevity, and pretty much no wonder it is still widely used and has been a big part of every backup infrastructure for decades. However, maintaining a tape infrastructure is often a challenging task, requiring dedicated staff, management costs, and properly planned retention policy and requirements. On the other hand, disks increased in their capacity and became, of course, more affordable, while also the public cloud is also competitive with budget-friendly offers for object storage. And that's when the cloud becomes a perfect fit for archival needs. And this is where tape steps back into the game. Cloud is object and it needs to talk to your storage via the object API, which quite often might become a problem for the backup solutions that usually talk file, block, or can do cloud natively, but at high cost. So that's where StarWind VTL is used. It provides the emulated physical tape object that talks any S3 compatible cloud. So StarWind VTL is a Windows native application that can be installed on top of Windows Server bare metal or a virtual machine with Windows Server operating system and works in conjunction with your backup software. So StarWind VTL emulates physical HPE LTO7 or LTO8 tapes and presents them over the iSCSI to your backup software. Now, the actual backup job is performed by the backup software. And based on the configured retention policies, StarWind further automates the process of sending, deleting, and storing tapes on the local storage or in the cloud. And it supports Azure, AWS, Wasabi, Backblaze, and other clouds that use the S3 compatible object storage. As for the retention settings, these are flexible and can be completely tailored towards your requirements. Essentially, StarWind VTL would first utilize the local storage of the backup server to create virtual tapes and leverage your backup software for writing data to them. And after that, you can set it to automatically offload data to cloud and remove the local copy once data reaches your cloud of choice. So basically, after storing the data on virtual tapes, you have a variety of choice for setting the retention policy to keep data both on local and cloud storage, remove virtual tapes from local storage after they are replicated to cloud, or keep them both locally and in the cloud for the specified amount of time. So now, with all that taken into account, how StarWind VTL actually fits that 3-to-1 backup rule? Well, by being able to keep a local copy and automatically uploading tapes to cloud, StarWind VTL can simply become a tool to store your data offsite in cloud for archival purposes, and AWS, Glacier, or Azure Archive tiers are quite a good fit for this with low dollar per GB pricing. And since you can set retention as per your requirements, it can be also used as the local backup copy. But again, to stay clear on this, as we noted previously, StarWind VTL always creates a local copy first, and it can be removed only once data reaches cloud. So you of course need to account for this when planning to use VTL on your backup server and properly calculate the storage required. So now let's take a look at how to properly deploy the StarWind VTL. So in my lab here, I already have the VM backup and replication as our backup software installed, and the HPE tape drives also installed. And let's then start with the actual StarWind VTL deployment. So StarWind VTL comes as part of the StarWind Virtual SAN installation. So all you need to do is just download the StarWind Virtual SAN from our website for testing, and you'll have StarWind VTL as part of its functionality. So let's just select the StarWind Virtual SAN server, make sure we have the cloud replicator for VTL, StarWind Management Console, and PowerShell Management Library. That's it. Now, we do have a key already in our demo environment. So I'm just going to pick it up. And let's just wait for it to get installed. So what I'm actually intending to show you here today is the installation, setting up StarWind VTL device, and providing it to VM backup and replication server, and of course configuring the cloud replication. So it will take us a couple of seconds more. And great. And let's of course launch the management console. So if anyone is familiar with the StarWind Virtual SAN, So that's just the same management console used for both our virtual SAN and our VTL. So it offers us to choose the default storage pool, which is our E drive. So I'm just going to click yes. And now let's just open the management console. So here is our local backup server. So just to stay clear on this, we have everything in one machine: the VM backup and replication software and StarWind VTL. So now let's add the Vtl device. Let's just name it simply VTL1. And so we have an option here: fill storage slots with empty tapes after create. I tend to uncheck it because it will just create the 96 tapes by default. So I prefer to create tapes separately. So here we can create a tape, use custom paths if required. Number of tapes, well, let's create 2 tapes just for starters. By default, it will be 12 terabytes with the maximum size, but of course you can set the custom. And here are our 2 tapes with the barcodes and 0 space used. So now let's try and configure cloud replication. So we have a choice here for Amazon S3 and Glacier, Backblaze B2, Azure, Wasabi, and any other Amazon S3 compatible cloud storage. So to show you more how StarWind can work, let's pick Microsoft Azure as an example, and since it has several tiers. And now let's take our credentials from the Azure for our storage account, which will be demo VTL, the key, and the container name, which in our case is simply demo container. And the public region for Azure. Now let it verify our credentials. And here we already approach to our tape retention settings. So the first option, well, quite obviously, is to start replication to cloud immediately after the tape is removed from drive. So we can set it to never replicate and just to keep the copy on the local storage, or we can set the values in a number of days. So let's replicate immediately. The next option is to create new tapes automatically when the tape has been moved to the cloud. So this allows us to bring a portion of automation without a need to always manually check the number of tapes if there are free tape drives and create them manually and add to VM. Now we can keep the local copy forever, or we can delete it immediately after the tape has been replicated to cloud, or again we can set a value in the number of days. And let's choose just delete immediately from the local storage. Now the next setting, we can keep the copy in cloud again forever, or set the value in a number of days. Let's make it 2 days, for example. By default, the tape reaches the hot tier. So currently we have several options. We can always keep it in the hot tier by choosing do not move options. We can set the value in the number of days for which period we want to keep data in hot tier, which means higher pricing, but of course faster access and retrieval. Or we can set move during day policy, which is the fastest way to move from hot to cool tier. And then the same settings for the cool tier to archive. So again, I'm just gonna choose move during the day. And now also just to note, in the upcoming build of the StarWind VTL, we will already have the functionality of direct offload to Azure archive tier or to cool tier. And in case of AWS, we also have the ability to offload data directly into the Glacier tier while skipping the S3 tier. So let's apply our changes. And now let's go to Vim, see our tape infrastructure, and let's try adding our tape server, basically the local one. But before we actually do that, to eliminate the additional inventory job, let's first go to the iSCSI initiator and connect our tapes or the iSCSI. And since we are working with just the local server, we'll simply connect it locally. Now let's check our targets, and we have our demo VTL1. So let's just connect it again by the loopback IP address. And perfect. Now let's proceed in Vim and add our tape server. Now, since StarWind VTL is basically the emulation of the physical tapes, if we go to the device manager and check for our tape drives, we'll see 4 tape drive slots created for a single VTL Virtual Tape Library device. And we have successfully added the tape server, and let's start the tape library inventory. And of course, it will take a couple of moments. And success, which is great. So now let's go ahead to our media pools. By default, the 2 tapes reach the free media pool. So we can create another media pool and name it properly. We pick the standard media pool. Let's name it according to our cloud destination. Simply Azure. The tape library. Media set name if required. The data retention policies, I just leave them by default to save your time. And finish. Okay, so now let's actually make a testing backup job. So now there is a difference between files and virtual machine backups job. Most of the backup software, and in this case, the VM, cannot perform the virtual machine backups directly to tape. So in case of virtual machines, we'll need to first perform backup to the local disks or to the attached storage, and then perform the backup copy job. However, for the tapes, most of the backup software allows backing up files directly to tape. And now let's just pick some files for our testing. And I remember I have the HP tape drives files right here. And I believe this will be enough for us to show the actual upload. So just 7.6 megabytes to make it clear and to make it fast. Now let's go next. We set our Azure Media Pool, configure full backup, incrementals. Now we have 2 important options here when it comes to Vim. The first one is Eject Media upon job completion, which basically serves as the trigger for StarWind to start uploading tapes to cloud. So if you leave this unchecked, StarWind VTL will be simply waiting there for the tape drive to be freed. And the export current media set is what later allows us restoring tapes from the cloud storage. And let's run our testing job. So as soon as Vim finishes the backup job, we will see the tape drive moved from tapes to the offline shelf. It will be first kept on the local storage and then moved to cloud. And this will take a couple of moments for Vim to complete the backup job. And 99% looks good. So we should shortly see our cloud with our barcode currently on the local storage and now uploading to the cloud. And as you can see, its status changed to uploading completed. The tape has been removed from the local storage and is now kept only in cloud. And as per our settings, the new drive has been added automatically. So now I believe we can check our container and see if the tape is really there. So just take in mind the barcode. Let's go to our demo container. And as you can see, we currently have quite a lot of tapes here already in different Azure tiers. Most of them have already been moved to the archive. Some of them are kept in cool tier, and some of them are also in the hot tier. So let's try to find our tapes. I'm just showing you that this is our demo stand that we use and actively upload tapes there. So we have quite a pile of those, of course. And I hope I did not miss our tape. And there it is. So the tape file and two metadata files. Currently in the hot tier, and according to our intention settings, it will be gradually moved to cool tier and then to the archive tier during the day. And now to show you shortly the actual restore process, what we first need to do, well, we first want to restore our files. So here is our chain with HP tape drives. So we will need the following tape. Now what we need is to download the tape. And since it's currently in the hot tier, this should not take a lot of time. So the downloading has been started. And let's just wait for it to appear on our local storage. And it is completed. So now all we need to do is just insert the tape. And we can then proceed in Vim. And we can choose the original location or just some other. So let's take just the E drive to make the difference. And I'm just going to leave the existing file also. And of course, the actual restore will take some time for the VM. So perhaps you have some questions you want to ask. So we might now very well take time for this while waiting for the restore process. So please, if you have any questions, feel free to ask them in the questions box. And we have this completed. So if we check our new volume, we see our structure and HP tape drives restored here. So pretty much StarWind VTL, as you probably can see, is quite a simple tool to work with. It provides the flexible and automated retention settings for sending data to cloud of your choice, and by providing simple access to cloud storage and specifically to such archival tiers as Azure Archive or AWS Glacier, it can very well be that part of the 3-to-1 backup rule by replacing the common or usual offsite copy with the archival copy in cloud. And so once again, if you have any questions, just feel free to ask them in the questions section box. And the question, so does the VTL provide an air gap solution to combat ransomware accessing your tapes locally and offsite cloud copy? Now, that's a good question. There are a lot of talks behind the tapes and emulation of tapes, if they are ransomware protected or not. So it always depends. While there might be the ransomware that cannot encrypt the emulated tape itself, it can still very well encrypt the directory where it is stored. So by default, as such, StarWind VTL emulated tape is not ransomware resilient, but ransomware resiliency in any solution is basically the approach. So that's first of all of keeping the backup outside of the primary data, assign a separate user and password to access that server, and of course avoid the domain administrator credentials usage, creating dedicated user for the backup software, and of course keeping it outside of the primary domain. Otherwise, to additionally answer your question, StarWind VTL works very well with the AWS and Azure when immutability is enabled. In that case, yes, it will be ransomware protected, because even if the ransomware encrypts all the data or someone will remove all the tapes locally, even in that case, the data will still be left intact in the cloud, where you can further restore them and access your data. And also, for anyone wondering, the record of this webinar will be available on our YouTube channel and on the StarWind website in a week or maybe more. So in case someone was late, don't be afraid. You will be able to see the record of this webinar, of course. And additionally, as you might have noted, there is the inventory job that should be performed once you create new tapes, or even when the new tapes has been added. So this is part of the manual process that should be done. However, we have the PowerShell script that automatically is triggered when a new StarWind tape is created. So it's automatically triggered to perform the inventory and add tapes to the free media pool. So when we'll be sharing the record of the webinar, the link to the script and also other useful materials for the StarWind VTL will also be in the attachments. So this will be actually the end of our webinar. I'm really grateful to everyone for joining this webinar and for your attention and for your time. So wish you a great rest of the day. Take care and hope to see you on our other webinars upcoming. Thanks everyone and goodbye.